Hello, good afternoon, Internet. Welcome to another NL Math Man math stream. I hope social distancing is finding you well. You're keeping spirits up and ready to do some math work. Yeah, that's how we keep focused, right? That's right, doing math work. Hope you're enjoying another little picture of my fuzzy buddy over here. It's a little Smoky. It's in winter, obviously. It's not just like fake snow that we threw over him or something. That would be mean. And over here, this other picture over to the side, when you see me zoom on by it there. Look at that. Look at that. You can see me zoom on by. That picture there, I took that one in Green Gardens. Right? That's anyone here? Yes, NL Shelley. Yes, Peter is here. I am definitely here. I don't know about anybody else, but thanks for being here as well. I will get to the topic you suggested in a bit. Okay, so yeah, this is a picture of Green Gardens. I took this one. I took that one myself. My dad and I did an overnight hike through the Green Gardens Trail in Newfoundland. It's on the west coast of the island, right, in Grossmore National Park, which is a gorgeous park. Um, yeah, if you're ever wondering, like, I don't know, if you're seeing this and you're from someplace else, you're like, what in the world's in Newfoundland? Why does anybody want to go there? I'll tell you why. Hiking. Hiking is one reason for why. Let me tell you, that park is absolutely gorgeous. This I believe this trail is currently closed for renovations, but yeah, it's definitely worth checking out. This is Green Gardens. It's down along the western coast of the island of Newfoundland. St. John's is a wonderful city for hiking as well. We have quite a few really nice trails around here. Like Sugarloaf Path is one of my favorites. Deadman's Bay Path is really good. And just the East Coast Trail in general that winds down around the Avalon. But this one is from the west coast of the island. And yeah, it's right outside this campsite that they have set up. They have spots set up for people who want to do overnight. So they have like just like flat places where you can pitch your tent, and they've got like boards across the bottom of it, so it's a bit warmer and flatter, and it's got little hooks there that you can hook your tent into, right? So it's super convenient. Anyway, that is just reminiscing about no sound last video. This really happens too often. Yeah, I know, Shelly. I don't think that's my end, unfortunately. I'm sad to hear that. I think that might be your end. Uh, my um, my internet has been spotty, so I imagine your guys is as well. Right now, I seem to be okay. I've dropped 1% of my frames so far, so from my end, the video should be fairly on point. You can always try. Excuse me, I'm phlegmy. You can always try reloading the stream. That should help. Or maybe just wait a few minutes and hopefully it'll right itself. So I'm going to switch on over. I'll switch back over to my working display over here. So we see the stream is starting soon. Topics for today: compound shapes and surface area, linear functions, volume of regular shapes, outliers, central tendency, polynomials, and intercepts. Yeah, thanks, Esther. Yeah, I think it is fine as far as I can tell, and I've got some decent feedback here from the program that I'm using. Okay, so I'm going to switch on over then. Like it says here, I'm going to start off with compound shapes and uh, compound shapes and surface area. Renetta, this is one that you're going to need to know. So how about actually I'll start in with the ones you asked specifically, Renetta, and then I will carry on with ones that Ashley asked for. But they're on the same topic that you're doing. It's just the very same topic comes up again in the first of the level 3 courses, and that's the one Ashley's currently on. So Renetta, if you hang out after I do your question specifically, it'll keep being useful to the same topic that you are working on for a little bit. Then let's see. After that, I will probably get to the ones Esther wanted. So that'll be outliers and central tendency. So I'll do this one here first, this one here second, this one third. Betty Ann, if you're in chat, you can drop something in as well. That'll be linear functions here, form and graphing. If you're around, just let me know. Otherwise, I will link this to you afterwards. And I believe Tia asked for polynomials and intercepts, though I think she's not going to be able to make the video live. So I'll do that one last and just link it to her afterwards. Okay, a bit more info than you guys need to know about my schedule, but hey, might as well be transparent, right? Although right now I've got, see this over here? I'm yeah, I'm really scraping the bottom here today, folks. This is yesterday's tea bag. Yesterday's tea bag back from the dead. It's mostly just hot water at this point. It's hot water with sort of like the idea of tea. It's like, you know, if you had a pot of hot water and you like moved it near a pot of tea and then drank it, that's about the level of tea flavor that I'm getting. But yeah, I haven't got my grocery order yet, but I mean, you know, I totally understand that. I mean, I'm sure they are run off their feet busy with the amount of orders that they have. So it being a few days later than they said, it's like that's ain't no thing. I'm will still be very grateful to get it when I get it. Okay, so Renata, this is your page 190. So you asked for these. So this is Prism Math Purple. Actually, Renata, how's your actually, Renata, right, yes, where you're saying your video is a bit off. I'm going to start with the I'll start with the ones that Ashley asked for, because if your video is a bit messed up, then maybe you'll want to wait a second. So here we go. And Renata, you will see that this is very similar to the ones that you were doing, just this is the way that it's handled in sort of the next course. So I'm going to do that and then this. So it's not Prism Math. This is Math 1102A Unit 3. Right, and I'm going to work down through the notes a little bit. Oh, Shelly, and Ella, you saying you're all right? You're good now? Okay. Tell you what, I'm gonna keep waffling. I'm gonna keep this is good. It's good. It's really decisive, right? Okay, so I will do the Prism Math Blue first, like I said. So this is gonna be page 190. There we go. So page 190. And Renetta, I believe you asked for number 5 on this page, number 4 on the next one. Okay. A cube with each dimension 100 centimeters has a volume of 1 cubic meter. How many cubic centimeters are there in 1 meter cubed? Oh, okay. That's interesting. I like this one. Okay. So this is a really important one to get because it shows an issue that a lot of people have with converting between area and volume and linear measurements, right? So if we have a linear measurement, say our linear measurement is 1 centimeter, right? Actually, I'm gonna pick feet and inches first. I'm gonna pick feet first and inches because I know we're not dealing with imperial right here, but this is one of the times when it's actually a decent example. So let's say this was 1 foot, this direction, right? And this was 1 foot, this direction. That's going to make an area that we call. Glad I like it. You don't? Well, you'll like it all right in a minute, maybe. 1 foot squared, right? Because 1 foot by 1 foot is 1 foot squared, of course. But then, say we've got another rectangle over here. It's the exact same shape, though, or the exact same square. But instead of calling it 1 foot by 1 foot, I'm going to call it 12 inches by 12 inches, right? Because oftentimes, if someone said, well, 1 foot squared, well, a foot is 12 inches, right? So 1 foot squared is 12 inches squared. No, it's not. It's not at all. Because a square foot is 12 inches this way by 12 inches this way, which means it's actually 12 times 12, so 144 inches squared. So 1 foot squared equals 144 inches squared, right? And it's because we square the conversion factor, right? I mean, that's literally why it's called squared, right? Something squared is the amount of space taken up by that dimension, you know, as the width and as the height, or the length and the width, rather. But say for this one now, we're dealing with metric. So let's say instead we had a shape, an area. So I'm just going to do area first, and then I'll do volume after. Say we had an area. I shouldn't have eaten just before the stream, right? Now I'm phlegmy. We have an area here that's 1 meter, say by 1 meter, is going to give us 1 meter squared, right? But if instead, now I think you see where I'm going with this from what's above here, say we converted those side measurements into centimeters, right? So 1 meter by 1 meter, this is going to be 100 cm this way. This is going to be 100 cm this way. But is it going to be 100 centimeters squared? No, it's not. It's going to be 100 times 100. So it's actually going to be 10,000 centimeters squared. So from this, we know that 1 square meter is actually 10,000 square centimeters, like that. So now, instead, let's imagine that we had a cube. I'm not going to go through all the work of doing a single point perspective drawing like I did before. I'm just going to freehand this guy. So instead now, imagine that we had a cube like this, right? It's 1 meter long, or 1 meter wide, and 1 meter high. So this is going to be 1 meter times 1 meter times 1 meter equals 1 meter cubed. And that's going to be the volume. Because remember here now, we're dealing with volume. We're not dealing with area. So the volume of this one is going to be 1 times 1 times 1, which is just 1 meter cubed. Yes, good morning, Brittany. Yes, thanks for dropping by. Leave a message in chat if you have any questions. But yes, it is indeed the afternoon. Thanks, Renetta. I'm usually very good about that, right? I'm usually pretty pedantic. Whenever someone walks in, if it's 12:01, like, good afternoon. Yeah, I mean it's important. It's important to be correct, right? Technically correct is the best kind of correct. So say if we have that's reasonable. So say if it's the same cube, I know this one looks way bigger. So this is going to be 100 cm this way, 100 cm this way, and 100 cm this way, right? It's the same. 1 meter, 1 meter, and 1 meter is the same as 100 centimeters, 100 centimeters, and 100 centimeters. But I think that you see where I'm going with this now. The volume is going to be 100 times 100 times 100, which is going to be a 1 with 6 zeros, which is otherwise known as 1 million. All right, so question 5 then. A cube with dimension 100 centimeters, so this is it, a cube with dimension 100 centimeters, that's this guy right here, right, has a volume of 1 meter cubed. That's right. Right, so this one and this one are the same cube, even though I've not drawn them the same at all. 243 Prism Math Purple. Sure, I'll get to that. I'll write that on my list. In general, Brittany, if you want to, you can fire me off an email at any time of the day or night. Like, I'm not going to respond if it's outside normal hours, but I will see it, like say the next day or whatever. So that way I can prepare stuff like what I've got done up here, right? Because you're over here on the side. I had to, this one over here, I had to take I don't have a digital copy of Prism Math, so I had to take a picture of it and, put it in there, right? So if you let me know in advance, I can rig up this kind of thing. But either way, I'll just point the camera at the book and we'll do fine for today. So I will do page 243 there now in a bit. So, Renetta, your question 5 then. Cube with dimensions 100 centimeters. How many cubic centimeters? Well, it's a million. Let's see. Yeah, if you were asking about that one, I will also do question 7 on this page too. just to so we have a bit more examples there of the same topic. So then question 7 on this page. Anne has 500 cubes, each with edges 1 centimeter long. How many more cubes does she need to fill the box? Okay, so the box, well, first we got to figure out the volume of the box, and then we got to figure out the volume of the cubes. Or, I mean, we got to figure out both, not necessarily in that order. Once we've got that, it's just a simple subtraction. Oh, nope, scuffed that one. Don't mind me. That box is a bit, it's a bit wonky. It's a wonky veg box. Um, okay, so this one is 7 centimeters high, 8 centimeters wide, and 10 centimeters long. Well, we know the volume of a rectangular prism is just length times width times height. So here it's going to be 7 times 8 times 10, which is 56 times 10, which is 560. Easy. Right? So she's got 500 cubes. Well, each of her cubes, the cube she has, I'll go ahead and draw out a diagram just so we're aware of what it is that we're talking about. There we go. So her cubes have edges 1 centimeter long each. So it's going to be 1 cm, 1 cm, and 1 cm. So the volume, this one, the volume of the cube is just going to be 1 times 1 times 1, which equals 1 centimeter cubed. So now, if she has 500, well, how many does she have left? That's easy. We're just going to do, because each of these is 1, right? So 500 times 1 is just 500. So it's going to be 560 minus 500 equals 60. So Anne needs 60 cubes. There we go. Right? So that's Prism Math Blue, page 190. You also asked, I believe, about Prism Math Blue, page 192. Prism Math Blue, page 192. So let me, come on now. There we are. Full screen this one too. There we go. So we can still check it out over there on the side. And you were asking about question, what question was it? Number 4. Number 4. So a wastebasket shaped like a triangular prism has a volume of 162,000 centimeters cubed. The area of its base is 1350 centimeters squared. What is the height of the wastebasket? Okay, excellent. That's a good question. Although I say that about a lot of these, don't I? He just likes math questions for some reason. I don't understand. Okay. Break out the Jim Gaffigan. And all else fails, just sort of doing a side in a high pitched voice. That gets laughs, let me tell you. All right, no shade at Jim Gaffigan. Jim Gaffigan's a fine comedian. So the wastebasket is kind of like this, right? And here we're like looking down inside the basket so we can see sort of this side going down there like that. Right? It's open. It's open is what I'm is what I'm trying to indicate because it's a basket, right? That's where you throw the stuff. Anyway, uh, volume. So we know the volume of the triangular prism is going to be what? What is the volume of the triangular prism? Well, the volume of any regular shape. All right, so I'm going to write this out over here. And this is what I'm going to get onto in the ones that I talked to do for Ashley as well. So Renetta, that's one reason why these are going to be useful for both of you. But the volume of any regular solid is volume is equal to base time BH, where this is the area of the base, and this is the height. And then maybe I'll write out another note. I'll write out another short note here just to define that regular solids, I'm going to say have constant width. Um, or I'm going to say do not taper. Yeah, that's a good way to phrase it. So a regular solid would have a constant width, or do not taper, is what I'm saying here, right? So like a triangular prism, that works because it's the same all the way up, right? If I took a rectangular prism, like say this nice dice log here, this is a regular solid because it's the same sort of width the whole way across, right? But I don't see one at hand right here. Maybe like the tip of the pen there, right? This a cone would not be the same as what we're dealing with here now for these regular solids, right? Because a cone tapers. It's narrower at the top than it is at the bottom, right? Whereas a cylinder, like a can, it's the same area at the top as it is at the bottom. And this one here that we're dealing with in question 4 is indeed a regular solid. So because it's a regular solid, we know that the volume is going to be the area of the base times the height. And what's the area of a triangle? Well, it's half the base times the height of the triangle. I'll use lowercase h to mean the height of the triangle. And then I'll times that by a capital H, meaning the height of the full shape. Right? So, give me 1 second here. Okay, so the wastebasket has a total volume of 162,000 cubic centimeters. And the area of its base is 1350. Oh, but we didn't need this part here because they've already given us this full thing. They've already given us the area of the base. So, or we could also call this the volume of the triangular prism is equal to just B times H, right? It's the same for all of them. But we're given the volume, so that's 162,000. And then we're given the base, which is 1350. And we just have to solve for H. So at this point now, all we've got to do is divide to get this number out of here. So we're going to have 16,2,000 divided by 1350 equals H. And to break out my good friend TI-84. 120. 120 equals H. So it is a 120 the height of the wastebasket is 120 centimeters. Not to be too pedantic, but generally when we have a word problem, I would expect the answer to be written out in words too, right? Like so. So now the next one, actually there wasn't a next one that you asked, was there? Tell you what, I'm going to talk a little bit about question 5 as well, because this is, like I said, this is a very good question because it's very similar to the ones that you'll see later on. So basically what we're doing here is the same stuff that I was talking about for you yesterday, but now it's volume instead of area. That's really the only difference, right? Because what we have is a shape where there's a triangular prism sort of stuck on top of a rectangular prism, right? So this triangular prism here, drop back this way, really should do these as a point perspective. Oh, you can see if you got it right. Yeah. Okay. So I'm going to go through this one here. Uh, that's an all right. That's not bad. I really should go with the point perspective, right? Because when I do point perspective, I'm much more pleased with how my drawings look. All right, so never you mind the rest of the rest of this. But what we have now is let's see. We're told this line here. We're told this one is 0.8 in there. We're told the width from here to here is 3 meters. It's 3 meters long as well. And we're told the height here is 2 meters. All right, so I'm going to do the volume of the bottom part first. Because the volume of the bottom is super easy. The volume of the bottom is just the volume of a rectangular prism. The volume of a rectangular prism is just V equals the three measures multiplied together. Easy stuff. So that's going to be 3 times 3 times 2, which is going to be 18 cubic meters. Right? Then the volume of the top. Well, the volume of the top is almost the same because it's a triangular prism. Right? And again, like I mentioned over here, the volume of any regular solid like these is just the base times the height, right? You don't really need to let you away with it's not being graded. Well, I mean, no, for these questions, for these courses, Prism Math Blue, I do the Prism Math ones. I do still grade the notes because there's no other thing in that course really. For the level 3 math, I'm not grading the notes over social distancing. Um, excuse me, but I will be answering any questions that you have on the notes, and I will be grading all of the assignments and the review sheets and any well, all the assignments, all the worksheets, and then any review sheets you choose to do will be graded as well. And the tests, of course, and the exams, but obviously. The volume of the top then, so the volume of a triangular prism, like I said, is going to be the volume of the base, so it's going to be a half times the base times the height, the area of the area of the base, times the height, or in this case, it's going to be times the length, but you know, whatever. So the volume of the triangular prism is going to be a half times the base of the triangle is 3, the height of the triangle is 0.8, and the length of the whole shebang is 3. All right, so it's going to be 3 times 3 times 0.4, which should be 3.6. Yes, of course. So that equals 3.6 meters cubed. Right? And then the V total is just going to be 18 plus 3.6. So it's going to be 21.6 cubic meters. There you go. Prism Math Blue, page 192, is 21.6 cubic meters. All right, that's a good segue then into this next topic. Back over to my working display. Now we're going to go to math. Oh, no, that's one for after. Math 2102A study guide. That is where I'm at, isn't it? In it. Yes, here we go. Good stuff. Okay, so unit 3 of this course is measuring length, which is really just the same topic that we were dealing with just now, right? I'm going to skip down through some of these first ones because I think they're fairly straightforward. Actually, if you have any problems with these when you're going through them, please let me know. But I don't anticipate any major problems with these ones because this is stuff that you've already done a considerable amount on before. What I would like to cover is this example 4. I'm going to work through this one. And Renetta, this is a good one for you as well. It's similar to the ones I was doing yesterday on that extra sheet that I made up. So here we have to find the area of this figure over here. So I'm going to zoom in a bit. Find the area of this figure. Now, how are we going to find the area of that figure? Well, first up, like we don't know how to find the area of like a U shape, but what we do know how to do is to split it into shapes that we can. So this is math 1102A unit 2. This is the unit 2 notes. So I'm going to go ahead and draw out a copy of that figure. So this is example 4. And it's already sort of split up for us, right? Because we've got a rectangle on top and then a semicircle below. I'm going to draw this one freehand. It's all right. So we've got a 23.5 feet this way, and we've got a 48.4 feet that way. Well, the area of a rectangle is just length times width, of course, right? So here, the area of the rectangle is just going to be our 48.4 multiplied by our 23.5. And I'm not going to do that one in my head. 48.4 times 23.5. That's going to be 1137.4 square feet. Easy, right? But then how do we get this down here? Well, this is a semicircle, right? So it's half a circle. So what's the area of a circle? Well, the area of a circle is pi r squared. So what's the area of a semicircle going to be? Well, it's just half a circle, right? So how do we do half of something? Half pi r squared. Not really that hard when you think about sort of um, what the actual situation is, right? Like you're not always going to be given area of a semicircle on your formula sheet, but you should be able to figure it out on the fly, right? So here now, well, we had to find the radius of this circle. And how do we find that? I don't see anything here telling me the radius. We do know, though, that from this side to this side, it's going to be 23.5. So we know that the diameter of the circle is 23.5, because this is the distance from one side to the other going through the middle, which is what the diameter is. We also know that the diameter is equal to twice the radius, right? So we know that 23.5 is equal to twice the radius, so the radius is going to be half that, right? So that's going to be, what, 11.75? 11.75 equals, what did I... I'm not sure why I did that. That was a pi, not an r. So 11.75 is going to equal r, right? That sounds right. Okay, so now we know that the area of the semicircle is going to be the area of the semicircle, half pi times 11.75 squared. So that then is going to become 11.75 squared times pi divided by 2. 216, I'll just call it 216.9. 216.9 feet squared. So then once you've got that, right, we found out the area of this part. So that's this area here. We found out the area of this area here. So now we just have to add them together. Area total is going to be 1137.4 plus 216.9. 1554.3. Here we go. That is our answer for this one. Let's see if this agreed with me. Oh, they called it 1354.2. I don't know. I like 0.3. I think it doesn't really matter. It's just the way that we rounded them. And so the number of bags of seed, well, you're going to take that and divide by 350, right? Because this is how much lawn the guy has in total. So to find out how many bags of seed he is going to need, it's going to have to be this number, so 1354.3 divided by the 350 feet per bag, right? And that's going to give us, about 3.9. So he needs about 3.9 bags, which means he's got, like it says there, so he has to buy 4 bags of seed. Right? Jack has to buy 4 bags of seed. Again, not to be super pedantic, but in general, when it's a word problem, we will be expecting the answers to be in words as well. I'm going to go on to show one other example from this course here. Yeah, I think very briefly, I'll do this example, and then I'll do the other one that I wanted to get to, and then I'll either watch I'm going to watch our daily government health update today. We're going to watch that one together on stream, and I will get to your questions next after I get these next two examples done. Though we might be taking a brief break to pop over to NLGov Twitter and watch that live stream. There's apparently some announcements about education forthcoming today. Is what the update said. So yeah, I think that would be relevant for us to know. So this is 3.4 example 1. So then 3.4 example 1, I'm going to call this one. So we've got a rectangular prism here. Let's see, I'm going to all right, not bad. Not bad. You know, just sort of going into the background, right? It's not a bad way to drop. We're sort of looking at it from the side down there. It looks like it's like a relic from Slay the Spire, doesn't it? Looks like I need to stop using my attack cards. I gotta pay attention here. Yeah. Although that's supposed to be a book, I think, in Slay the Spire, right? Isn't that the Art of War one? I think it's Art of War, right? Where you get extra energy if you didn't play any attacks last turn. Anyway, that's definitely rambling. 8 centimeters this way, 3.6 centimeters this way, and 2.8 centimeters this way. So it's asking for the surface area this time. If they were asking for the volume, that'd be super easy. Just this one times this one times this one, and you're done. Volume is just the amount of space that a shape takes up. But here we're looking for the surface area. And the surface area is the area of all faces added together. Right? It's not really an aside, but I'll still put it in a bubble. Surface area is the area of all faces added together. Right? Super important to know that one. So here now, if we know we need the area of all the faces, we know the surface area is going to be, each combination. We have to make sure that we have each combination here represented, right? So there's going to be a length times a width face, right? So we say a length times a width face. If this is the length and this is the width, then length and width are the top and the bottom, right? Because length is this way, width is this way. And there's going to be two of those, like I'm saying, because there's the top and the bottom. And then we're going to add 2 times the length times the height, right? So if this is the length and this is the height, right? Then there's the right side, and over here on the left side, there's 2 of them. And then we have to make sure that we have our other combination, which is going to be 2 times the width times the height. And if this is the width and this is the height, this is the front and the back, right? So we have to just make sure that we've got each different combination, an L and a W, an L and an H, and a W and an H. The order doesn't matter, right? Because multiplication it's commutative. That's right. Multiplication is commutative. So that one doesn't matter. The order doesn't matter. What matters is you have each of the pairs. So I'm just going to go ahead now and start filling this out. So I'm going to call this L, this W, and this H. So now I'm just going to go ahead and fill those guys in. 2 times 3.6 times 8 plus 2 times 3.6 times 2.8 plus 2 times 8 times 2.8. Okay. Yeah, Rogers did send out a tech, apparently. It took them a few days and a few tries, but it does seem like my internet has recovered quite a bit. Though we're not perfect today, but we're doing a heck of a lot better. So, you know, I guess I'm getting something in exchange for their routine price increases. I gotta say, like I get only internet from Rogers, and my bill has gone up by like $20 a month in the past year or two. It's crazy. I just get internet, nothing else packaged with it. Anyway, so now we're going to go ahead and do out all this number crunching over here. So it's 2 times 3.6 times 8 plus 2 times 3.6 times 2.8 plus 2 times 8 times 2.8. Now it's important to know that when I punch this in the calculator is going to follow order of operations like it's supposed to, right? Because so the calculator is going to calculate this part, and this part separately, and then add them all together afterwards. So my surface area here is going to be 122.56 centimeters squared. It's important to remember it's centimeters squared. Even though we're talking about a three-dimensional object, we're sort of talking about the two-dimensional faces of the three-dimensional object, right? Like if we go back to my nice dice log here, it's a very nice regular um, rectangular prism, even though it does have a bit of a beveled edge. But the surface area would be like this flat area here, plus this flat area here, and then this one, and then this one, and then also this flat area and this flat area as well, right? That's the same thing that we've done here now. They're all flat, which is why it's centimeters squared. Okay, so the last one that I want to do right now from this topic is going to be this next one. The surface area of the right cylinder has a diameter of 4.8 feet. Right? So it is super important to know these kind of ones, but this is sort of a callback to what I was just doing in Renetta's ones, where I talked about the triangular prism for the trash can. This is the same sort of deal, but now it's a cylinder. And I mean, honestly, a cylinder trash can, like I've seen a heck of a lot more cylinder trash cans than I have triangle trash cans. Okay, so this one now is still math 1102A, and this is, was it unit 2? No, unit 3. Yeah, I wrote it down as unit 2, but it's actually not. Yes, it's unit 3. Make a note of that to change it on my sheet. So this is going to be example 2. And here now we have a cylinder. So a nice oval, nice freehand oval. And we're going to draw that down, draw that down. And there we go. Not bad. Okay, and that's 12.6 feet high. And for whatever reason, the diagram doesn't show it to us, but it explains up here it has a diameter of 4.8 feet. So the diameter of any circle, this is not a circle, it's an oblong, but bear with me. The diameter of any circle is the distance from one side to the other passing through the center. So that distance is 4.8 feet. Okay? What's important to... Oh, right, we're not doing volume though, are we? We are doing... I was just saying how similar it was to the question that Renetta was doing. But yeah, we're talking about surface area now, not volume. Oopsie daisy. If it was volume, right? If we were doing the volume of the cylinder is just going to be the area of the base, which is going to be pi r squared times h. That's the volume. But we're not looking for the volume here. We're looking for the surface area. And just like the previous one, the surface area of the cone, of the cylinder, is going to be all the individual faces added together. Well, which parts do we know? We actually have enough to know all of them, but right from the start, well, we know there's a circle on the top, and there's a circle on the bottom, right? And what's the area of a circle? Well, we know over here the area of a circle is equal to pi r squared, right? So here we're going to have pi r squared for the top. There's also a bottom, so it's going to turn into 2 pi r squared, right? It it's coincidental, really, that this is so similar to the formula for circumference, because I mean it's not really coincidental, but in this case it is 2 pi r squared for this bit, so it is important to remember the squared, even though you'll be used to seeing 2 pi r without the squared being circumference. But there is another area on this shape, right? There's the top and the bottom, but there's also the sides. Now, how in the world are we going to represent the sides of a cylinder? Well, how about we look over here on my real cam over here. Hello. I should maybe have a scene done up where it's just me. It's just me talking big. Actually, I should have that. I'll do that for tomorrow. But imagine we had a cylinder, right? And this is the sides of a cylinder. But imagine then we took the sides of the cylinder like that, and we sort of cut it apart and we unrolled it. Cut it apart and we unrolled it. It becomes, of course, well, it is a rectangle, right? It's just a sheet of paper. You see that a rectangle, like so, can be rolled up into a cylinder, like this, right? But then, how do we find the area of a rectangle? Well, the area of a rectangle is just length times width. So how do we find what the length and width would be of this rolled up rectangle that is the sides of a cylinder? Well, we know this side, up and down here, that one's easy. That side is just the height, right? This side of the rectangle, as you see me fold it, that's just the height of the cylinder. So easy peasy. For our purposes, that was going to be 12.6. But then what's the other dimension? Ah, what indeed? If we look at the end, right here, we see that the distance around the end is the circumference of the circle in it. That's the distance. If we unfold it, this one across here, that is the distance around the circle. And we do know how to find that, because we know the circumference. Circumference is equal to 2 pi r, right? I was just mentioning that. So the two dimensions of this rectangle that are around the sides, one of them is the height, but the other one is 2 times pi times the radius. Right? Because this is the circumference. It's the circumference times the height is what makes the lateral area. We call this the lateral area. You'll see it referred to as that sometimes. And if you go online and you were to say punch surface area for a cylinder into Google, you're going to get something that looks a heck of a lot different than this. What you're going to get from Google is that your surface area is 2 pi r outside of r plus h. That's what you're going to get. Which is exactly the same thing. It's exactly the same thing as what I've got here, just I prefer this form because here I know it's not simplified algebraically as much as it could be, but the useful thing about this one is that it lets you see that this term is the ends and this term is the lateral area. So if you say, hey, I need to cut down and not take into account one of the ends, because say, for example, you've got something that's open on one side and you have to leave out one side, well, you can just cross out this 2 here, right? Whereas with this one, if you wanted to make changes to it, you would have to multiply it out to get this form first, and then take off one of these, then turn this 2 into a 1, right? So even though this method is not as simplified as this one, I prefer this one. So we will say surface area of a cylinder is equal to 2 pi r squared plus 2 pi r h. So then here now, I can just go and start filling these guys in. Well, we do know, right, this 4.8 was our diameter. So we know that the diameter is equal to twice the radius. No, I almost put in pi again. Diameter is equal to twice the radius. So 4.8 equals twice the radius. 2.4 equals the radius, right? So then over here we have 2 times pi times 2.4 squared plus 2 times pi times 2.4 times 12.6. And now we just got to go through, crunch those numbers, and then we will get that answer. So 2 pi 2.4 squared plus 2 pi 2.4 12.6 is going to be 226.19 centimeters, feet squared. Okay. 226.1. Oh, but that's probably the difference. They use 3.14. You see over here, we rounded a little bit, and this is a minor teachable moment too, because this comes up a lot. I get lots and lots of comments from students about this one. Teacher, why is my answer a little bit off what the back of the book says? It happens a lot. It happens most commonly with circles. The reason it happens most commonly with circles is because for whatever reason, your book and the notes insist on using 3.14 for pi. I guess just because it's simpler. It is because it's a smaller number with fewer decimal places. But if instead you were to do like what I did and use the pi button in your calculator, that one does not. See, that one actually does pi to, 10 decimal places. Right? So the more decimal places you go to, or 9, the more decimal places that you go to from pi, the more accurate your answer will be to what it would be in reality, but it will be a little bit off from what the book says. Right? So if you were to get, like I got, 226.2, and the book says 226.1, I ain't going to mark that wrong, right? Because I know that the difference is just the number of decimals of pi that you used. Excuse me, a little bit of heartburn today. I am definitely like I don't know. I'm definitely getting on to my emergency supplies. I had a can of not Fraser Farm gravy meatballs. No, I do have one of those though. Puritan Irish stew. That's what I had for lunch today. So I mean, you know that you're breaking out the survival food when you start heating up the Puritan. Let me tell you. I don't have any Chef Boyardee pasta though. That's a good one. Oh, as a kid, I used to love the Chef Boyardee cans of like chicken cacciatore. Chicken cacciatore was amazing, but like just the ravioli, just the or the penne they did. Yeah, they did like a penne and ground beef. Boy, it's good. Shit, I got some penne here. I don't have any ground beef though. Maybe I'll make penne for supper. So next up, yes, I wanted to do the ones for Esther. Let's see. We're going to switch over to watch the health announcement shortly. But first, I will get the stuff set up, and then after we're back, I'll resume watching it, or resume talking about it rather. But outliers and central tendency. Okay, so outliers and central tendency are well, not that one, although I do like this picture better than most of the things that we're doing today. Not that one, although I can go over that in a bit if we want more on that topic. Though we don't need more on that topic. Here we go. Dazzy, boy. All right, there we go. Check your understanding. Determine the range and identify any outliers in each data set. Now, Esther, I know you didn't ask for number 1 here specifically, but I do kind of have to do number 1 because I need the answer for number 1 in order to do number 2. So just bear with me briefly while I go through number 1. This is 3102A. I believe this is unit 2. Right? And this page is, what page is this? 85. Page 85, question 1. Question 1A, determine the range and identify any outliers. Well, the range, we know the range of any data set is just going to be the largest entry, subtract the smallest entry, right? So it just tells us sort of how far the set of numbers goes, right? So the range here, the largest that I see in this set is 50, and the smallest appears to be 3. Yeah. So the range equals 50 minus 3, so the range here is going to be 47. Pretty straightforward. Outliers. Well, the outliers in this set, let's see, you could say 3 and 6 are outliers because those are a bit lower than the others, but 50 is absolutely an outlier. Like 50 is way out to lunch, right? Because the next closest one to 50 is 34. You could even reasonably say that 34 is an outlier because the next one to 34 is what, 21? Like 3 and 6, well, there's also 10 and then there's 13. So it's a bit closer, right? But 50 is definitely an outlier. If you said 34, I wouldn't mark you wrong. And if you said 3 and 6, I wouldn't mark you wrong as well. But the only one here that is 100% absolutely an outlier is 50. Okay, so then B, I'll do this next one, and then I'll switch over and see if we can see the stream so I can find out what's going down. The range is going to equal the largest minus the smallest. Now here the largest is 18, and the smallest looks to be negative 20, no, negative 31. So we are going to have 18 minus negative 31. It's important to know that this is subtracting a negative, which means it's going to be adding. So the range is actually going to be 18 plus 31, which is going to be 49. The outliers then. Well, I mean, 18 is quite obviously an outlier. Like imagine this with temperatures, right? Like temperatures for the past 8 days, right? Uh, that 18, the positive 18 is definitely an outlier. You could even, maybe you could say the negative 7, but I don't know. I think negative 7 is fairly close. And negative 31 was also a 29 and a 21. So I don't think those ones are outliers. But 18 is absolutely an outlier in this case. But yes, let me take a quick refresh of the. Oh, they are live. Okay, here we go. Let me get some sound going. Switch over to my Chrome display. Give you my desktop audio. Now, why is this? Hmm. Why the heck is this not working? Oh, I see. I see why. Hold on. Nope. 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 That's not the window capture I wanted. Okay. Hold on just 1 second, people. I will have this live here now. So window capture, new window capture. There we go. Chrome. Perfect. Over here. Excellent. Here we go. And I know it's over my face, but let's okay. All right. So now I've got my desktop audio going. There doesn't appear to be any audio on the stream. So we're gonna watch this for the next few minutes because I want to see it and I want to stay live on my stream. I would like to be able to talk about this. So let's see if and when they come up. They got 755 viewers. It's a few more than I've got. I mean, just a few. Maybe I'll get a cease and desist for restreaming their announcements. I've got a feeling public health officials would appreciate them, me displaying it to my, 3 viewers, who I'm very, very grateful for, by the way. Not the, you never, that's a rule, right? That's definitely a rule. And you see a lot of comedians get this one wrong, and Twitch streamers do it sometimes too. But especially for comedians, like if there's a bad turnout for a show or something like that, or like people canceled and didn't show up, acts or whatever, and they'll like complain and moan at the show that, oh, there's nobody here. Well, don't complain to us. We're the ones that are here. Oh, here we go. Hi, Raka. Yeah, we're just gonna watch this for a minute first before getting back to the math. I'm glad you're here for math, though. on, Dwight. Come on, buddy. I'm pulling for you. Just had to increase the volume a little bit. Come on, buddy. Get some... Can we get this refreshed? Right, Twitter. Come on. There we go. That's what I wanted to hear. Mm-hmm. Okay.
Students in their time of need. And you need look no further than what's happening on Facebook and Twitter and Instagram and the social media platforms that we have available to us to see the tremendous work that our teachers are doing, staying engaged with their students, or indeed going above and beyond. So this is encouraging for students and all of us when we look at our own lives. And even today, I still get messages from teachers in my own life that encourage me and inspire me on a daily basis to keep going on and keep doing what we are doing on behalf of every Newfoundlander and Labradorian. I also know that this is a time of the year for high school students, well, you're feeling a little anxious because you're thinking about your post-secondary plans. But we can assure you that no student will be disadvantaged because of COVID-19. You'll have access to online learning opportunities. Your classroom will change. It could be your dining room, it could be your bedroom, it could be in some other room in your house. But your classroom will change from what you've been used to for most of your life. But you will have access to online learning activities. You will be given every opportunity to address any gaps in your learning, making sure that every measure is possible to support you. So at this point, I'd like to turn it over to Minister War to provide some further information on the K-12 system this year.
Thank you, Premier. The impacts of COVID-19 are bringing changes to our normal practices and routines on a daily basis. As our public health officials advise us, this is not a sprint, but a marathon. Given these circumstances and the knowledge that current restrictions due to the pandemic may continue for some time yet, public exams for this year are canceled. In addition, we have been in ongoing discussions with the English and Francophone school districts, and in consultation, we have determined that final exams for all high school and intermediate courses will also be canceled.
Okay.
As the Premier stated, our focus has been on ensuring learning continues for all students, particularly high school students and graduating students. The cancellation of exams does not mean that learning is ending or that the school year is over. In anticipation of the cancellation of exams, the school districts have been working to develop continuity of learning plans. These plans involve teacher support and the use of online learning platforms. For example, through the Center for Distance Learning and Innovation, otherwise known as CDLI, students can access high school courses and teachers can provide feedback, guidance, and support. The English School District also has its own mathematics YouTube channel with a variety of instructional videos and other resources for grades 7 to level 3.
YouTube, huh? Plebs.
Teachers will also connect with students through platforms such as Google Classroom and Google Meet, a video conferencing tool. We appreciate that students will want to know what their current standing is at this point in time. They will receive a grade to reflect their work to March 13th, the final day of classes prior to schools being closed due to the pandemic. The mark will be communicated to students by April the 22nd. However, as stated, and this is very important, learning is continuing and students are encouraged to engage with their teachers to ensure they maximize their opportunities with respect to achieving curriculum outcomes. For graduating students in particular, Level 3 students on track to graduate will be eligible to graduate. Options have been developed for students who may be at risk of failing a course and for students who may have already failed a course. And the district is in the process of determining the need for computer hardware and connectivity for students without access. The school districts will be providing further detailed information on these plans this afternoon. If at some point school resumes, the time remaining will be used for instruction rather than writing exams. I also want students to know that guidance services will be available to all students, and they will be available to schedule individual service or to join group sessions based on areas of interest. Professional learning opportunities will be available for teachers to support them in operating in a virtual learning environment. And I'd like to take this opportunity to thank Dean Ingram and others at the NLTA for their input and for working with us during this time. It's very much appreciated. We have had productive discussions to ensure the needs of students are being met and that learning will continue. Discussions have also been held with our public post-secondary institutions regarding entrance requirements for the September 2020 term.
This is important,
as
boys.
well as
Listen
the
to this
process
one.
for determining scholarship requirements. Both Memorial University of Newfoundland and Labrador and the College of North Atlantic recognize the need for flexibility so that students are not disadvantaged when applying for post-secondary studies. As mentioned, the school districts will be communicating directly with their school communities this afternoon with further information and details. Thank you.
Thank you, Minister War, for the information and the update on our K-12 system. It is really another example of how we're addressing both student and staff safety during this time. But we will, and we've made the commitment that we'll keep learning opportunities ongoing through the COVID-19 pandemic. And results made possible with the support from community organizations and industry, all critically important during this time. So I, too, want to thank the Minister, his department, our school districts, both English and
Some of us out here
Francophone,
working.
and as the Minister mentioned, the NLTA, and also these educators who have
Out here
kept in
schmoovin'.
constant contact with our students. So there's been a number of people involved in making this happen for our student population, all of us committed to the well-being and their education. So it is by working together in all areas that we will get through this together. I will now pass it over to Minister Hagee for a few comments.
Thank you very much, Premier. Well, we've seen again another increase on today's figures compared with previous days. We are, from experience of our other jurisdictions, not yet into our likely surge period. This is likely to come over coming weeks, and we are working hard to see if we can understand when that might be. But as has been referenced, this is a long haul, this is a marathon, not a sprint. And I think families now need to look to plans for Easter to have a more virtual gathering, and maybe even well into May and the usual traditional start of Newfoundland and Labrador's camping season. We have seen from other jurisdictions, however, the benefits in the way they have been able to reduce the demand on their healthcare system by physical distancing. And you've heard us mention this, and you've heard us emphasize it. But there is data now out there from places like BC that show very clearly that physical distancing and spending time apart is the key in our battle to reduce the effects of this pandemic. We have seen, and again, this is the time of the month, if not the year, when those of us who have smaller incomes and are more reliant on help see the checks arrive, be they GST or the seniors benefit from the province and these kind of things. And so it's natural that at this occasion people would want to go out and do their weekly grocery shop and stock up. We have seen examples of how it can be done well, and my attention was drawn today to Costco, for example, where they have good social distancing, orderly lineups, and limits of people in the store. But I've also seen pictures from Lewisport, from Corner Brook, of large groups of individuals hanging around outside the stores waiting for them to open, not practicing physical distancing. This is not acceptable. It is dangerous. Physical distancing saves lives. It is important as well that employers and store operators realize they have a responsibility too to adhere to Dr. Fitzgerald's orders. If there are instances that people are concerned about, then there are ways to report that. We have a public reporting form online, and I would encourage people to use it. We have seen a growth in the response to this form, and indeed it's a sad commentary that at least a third of those that have submitted forms are actually from outside Canada. It is a testament to what our department and what this country has done to try and support Canadians, that people are looking to us to help them in Nevada and Florida with their issues. It is sad, however, that we cannot assist them in this. We have only 4 outstanding issues under investigation by our RNC or RCMP. I have also been asked by those bodies to emphasize to the public that 911 should not be used for reporting issues around COVID-19 compliance. That is there for a different purpose. The form is there. There is an active response team from both RNC and RCMP to deal with these issues, and there is minimal delay in getting them addressed. Physical distancing is really important. I can't overemphasize its relevance. I've had reports again of teens in cars in groups of 4 and 5, and there is an onus on both the teenagers and their parents to be responsible in this matter, because at the end of the day, their actions will affect all of us. We are a social being. Human beings want to get together, and I understand this. And whilst we have stressed technology for keeping socially connected, again, there are challenges with the use of that. And I've been told and I've been asked to bring up the issue of dating apps. They are very common and have been seeing an increased uptake over this challenging time around COVID-19. But let me warn you, if you use Tinder or Grindr and you swipe right, you might get more than you bargained for. So please be careful when you use these applications.
He could have.
One of our challenges.
He got a good meme from yesterday. He could have made a joke there. You would have. Haggie's going to be the meme lord supreme of Newfoundland.
We are engaging
the lieutenant
provincially, nationally, and at the federal and international level to try and source these materials and these pieces of equipment which are consumable and in demand. This is not a situation that is unique to us. We continue to meet regularly with our healthcare workers to discuss how best to use PPE and how to use it on the basis of evidence. Our problem is what's called burn rate. It is being used at a rate that is up to 6 times greater than we would normally experience, even with our flu season here. We have had some deliveries, we have orders placed, but it is a challenge.
I'm going to move on here now from watching that, see if I still have anybody left watching the stream. Apologies there, folks, for the sound issues first. I didn't realize that. I thought I had the audio capture done up. Honestly, like that's a bug, I think. I don't know why I would need to have, because I'm capturing desktop audio, but for whatever reason, the sound from the stream wasn't playing through the desktop audio. I had to set up another audio capture. Anyway, y'all don't want to hear that kind of me rambling about this stuff. But yeah, anyone who's still here listening to my stream, thanks for sticking out. I really wanted to see the information about schools there. It's quite good to know that they're gonna push students on and they're gonna remove public exams this year. That's quite interesting. For this program that I'm teaching, that you guys are in, that doesn't really affect us at all because, as you know, we don't have public exams anyway. We award the high school we award the exact same credentials. We award grade 12 high school general or academic, the exact same as the high school system does, but we do it without public exams in general. So it's entirely possible that um, they're gonna be doing it a bit more like we do it for this year. Who knows? Maybe it'll be a work at your own pace thing where students just have an amount of work to get through. I gotta tell you, I mean, the way this system is set up for us, um, I have to look at this later. Send me the workings. Sure. Yeah, of course. I will send you the working afterwards, Esther. I'm going to get back to doing the questions there now in a sec. But if you got to go, of course, yeah. I mean, you do you, and I will, as always, send you the notes afterwards. But it's really interesting to hear that they're going to be removing public exams for this year. I think that's great. They also mentioned a freeze on the paying back the provincial portion of student loans, which is fantastic. I don't think anyone in this program would need student loans because pretty much everybody is funded for this program. But say if you went on and did another program after at university, well, never mind. I mean, I guess that wouldn't be starting until this whole thing was over anyway. So doesn't really matter. It matters for matters for people, those of us who still have student loans to pay off. It matters for them. Okay, but yeah, I'll be interested to see what specifics they come out with, right? As for say Mun and Kona's entrance requirements, because I'm sure Academy Canada will have to be paying attention to those entrance requirement adjustments as well, and how we will be able to accommodate students that have graduated this year. But I think we'll be able to do a really good job at doing that. One reason I wanted to do this stream, and I started doing this stream so early, partly because I've streamed to Twitch before and I know the basics of it, but also because I think that this program that we have is actually a good fit for distance teaching the way it works currently. And I think that this sort of a delivery model where I'm online for a few hours a day answering questions in a more class-like environment um, is a really good way of handling it. And in a class, when people ask questions, it's done in front of the full class. It's not just done one-on-one. Right? One of my issues with like people talk about using, I don't know, using Zoom or whatever or Skype. Right? One of my issues with that for the distance teaching is that it doesn't have the sort of classroom feel the same, because if you're talking to people one-on-one all the time, you're not getting a lot of the learning that happens when other people are hearing the stuff that other students are working on or other questions that they're answering, right? So I think a setup where students are given a schedule to log on. Maybe it's only 20 minutes, maybe it's only half an hour instead of being a full hour. But say if they say, oh, for this half an hour slot, you had to go, hang out in your math teacher's channel and you had to listen to the math teacher yammer on about, pea soup and outliers, right? But I think that's a lot better than saying, oh, if you've just got a question, just talk to your teacher one-on-one. The rest of the time, just be on your own. I think having it a bit more like normal school, but just being able to require like, and have it require as little as possible, of course, as little technology on the student's end as possible, which is why I think Twitch is a great option, or a technology like Twitch, because all the student needs is an internet browser, right? It's really elegant and simple for that. Clean, we could say it's clean, and we like clean, right? That's good. Little complexity as possible for the students. And I mean, the teacher should be able to learn to use OBS, right? Come on. I learned to use OBS. It's not that hard, right? Although, no, I say that, but I did just show like 5 minutes of the health update without the sound going. So, what do I know? maybe I should take the plank out of my own eye, right? Anyway, back to the mathematics. Yeah, I'm going to be going on for a bit longer here now today. I still have a few topics to get to, so hope you're tucked in and watching. Okay, so for this next one, then the range is going to be the largest minus the smallest. So here it's going to be 12 minus 1. It's going to be 11. Outliers. Well, the outliers in this set, let's say at the top there doesn't really seem to be an outlier because there's 12, then 11, then 10, then 9, then 9, right? But that one at the bottom, the one at the bottom fits my definition for what an outlier is. So we're going to have that one be the outlier. And then D, I'm going to do D in green. So we've got my 4 colors used. For D then, the range is going to be, let's see, what's the largest one there? 45.0? Yeah. So 45.0, and the smallest looks to be 30.1, right? 30.1. So range is going to be 14.9. The outlier there, well, the 30.1 is definitely an outlier. The 45.0 is not, because there's a bunch close to that. So I'm going to say that the outlier here is going to be 30.1. Okay, so now that I have these, I can carry on and answer the questions that you were asking for. The mean and trim mean for each data set in one. Remove the highest and the lowest value to calculate the trim mean. So I'm not going to do every single one of these because you do have the workings there in your book, right? But I will show you. So let's do 2A. I'm going to do that one. So the mean then, well, the mean we know is just the sum of the numbers divided by the number of numbers. So that is going to be the sum of all of them. So let's just go ahead and add those guys up here. 20 plus 34, another 20, 15, 3, another 20, 6, 10, 13, 16, 10, 50, 16, 10, 50, 21. Oh my God. That was seriously not on the whole time. Boy, I'm doing great today. Let me tell you, people. Let me tell you. Consistent stream supreme meme dream. Let me tell you. I am really plugging away over here at this math. Okay, so that's going to be 238. 238 divided by the number, let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 238 over 13. So about 18.3. Okay, so then we're going to find the trimmed mean. So the trimmed mean, I'm going to not count the highest and not count the lowest value. So I'm just going to write out all of the ones that I'm adding together for the trim mean. So it's going to be 20 plus the 34 plus the 20, the other 20, plus the 15, plus I'm going to leave out that 3, plus then the 20, plus the 6, 10, plus 13, plus 16, 10, plus 21. So I'm going to leave out the 50. Right? So now I'm just going to go ahead, and these ones are all going to be then divided by, let's see, it's going to be divided by 11 now. So that is going to be, well, it's going to be, I'm just going to cheat, 238, and it's the same as 238 take away 53, right? So it's 185 over 11, which is going to equal 16.8. Now, as you'll notice, removing the outliers did change the question drastically, right? It's down quite a bit more because now we've got the 3 out of there and we've also got the 50 out of there. So this is now what's called the trimmed mean. All it is just doing the mean again, but I have the highest and the lowest values removed. So I'm going to do the same for one of the other ones, Esther, and then you should be able to go ahead and do the other ones. So say I go do B here. The reason I'm going to do B is because B does have a little bit of a wrinkle because B is dealing with negative numbers. Negative 16 plus negative 11. I'm going to put brackets around all of these ones. Plus negative 7 plus negative 29, just to show you exactly what's going on here. Negative 31 plus negative 18 plus negative 21 plus 18. Now this one's not a negative, right? And we're going to be dividing that then by the number of numbers, which is 1, 2, 3, 4, 5, 6, 7, 8. That's going to be divided by 8 numbers there, right? And that's going to be, so if I was to put them in here in this calculator, there are several different ways that I can add them. I can add negatives, or I can just subtract, right? But we start off with a negative 16, and it's going to be minus 11, minus 7, minus 29, minus 31, minus 18, minus 21, but then plus 18 here at the end, right? Because that one's a positive. And I'm going to get negative 115 over 8, because there's 8 numbers. Negative 115 over 8 is going to give us negative 14.4. We'll call that negative 14.4. And this is the mean. So not the trimmed mean, just the mean. Right? Then if we want to find the trimmed mean, well, then we're going to have to get rid of some of the values. So for the trimmed mean here, we're going to get rid of the highest and the lowest value, right? So that means we're going to get rid of this negative 31, but we're also going to get rid of this positive 18. So to be very thorough and write the whole thing out, right? So we're not going to have this 31, and we're not going to have this 18, because those are the outliers. Well, we don't necessarily know that they're the outliers per se, because for trimmed mean, we take the highest and the lowest value and cast those ones out. We don't necessarily only do it if it's an outlier. Right? We're just always doing the highest and the lowest one. So now it's going to be a negative 16 minus an 11 minus a 7 minus a 29 minus an 18 and minus a 21. So that's negative 102 divided by 6. And that now is going to give us negative 17. So as we see, the difference between the mean and the trimmed mean for part B is fairly significant, right? The trimmed mean, negative 17. The mean itself, negative 14.4. Okay, so that's enough for question 2, I think. The range of the data set, the measures of central tendency of the data set. Yeah, Esther, I think that this will probably be enough to get you started on this topic, right? Because I do want to leave some of the material for you to do. So I'll tell you what, take a shot at question 3 now that I've sort of explained how you do this one. So the rest of question 2 and then question 3 should be a good example. And then if you have any issues with that one, I'll go over the rest of that then tomorrow. Okay? Or whenever you want me to for that one. But I think that should be a good intro to help you get through that part. Next up, then, I'm going to do linear functions and graphing. So I've got a few to work through here in this one. So hopefully someone will be around to benefit from this one. I'm going to switch over to 1101C. Here we go. So Betty Ann, this is your questions. They appear to be starting about an hour and 40 minutes into the video. So this is math 1101C, assignment 1. Okay, so we got a few that I want to cover here. Let's see. Question 2 is my first one. So question 2, what is the slope of the line passing through those coordinates? Let me zoom on in. No, zoom out a touch. There we go. What is the slope of the line passing through negative 7, 5 and negative 7, 8? So negative 7, 5, and negative 7, 8. What is the slope of the line? Well, we can do the when in doubt, draw it out, right? I always do say when in doubt, draw it out. But here, let's do the slope. Let's do the slope equation, where we have the slope is the change in y over the change in x, which is y2 minus y1 over x2 minus x1, right? So now let's go and just fill those in based on this equation. We're going to end up with, remember, it's x comma y, right? So y2 is going to be 8 minus y1 is 5. x2 is negative 7 minus x1, which is negative 7. So then we're left with 8 minus 5 is 3. Negative 7 minus negative 7 is the same as negative 7 plus 7, which is 0. So now, what happens? I'll tell you what happens. It's undefined. Why is it an undefined slope? Right? Well, you can't divide by 0, so what the heck is going on here? Well, when in doubt, draw it out, right? Who's ever said that before? Nobody. Nobody has ever said that phrase before. It's a brand new thing that the math teacher on your stream just came up with. Okay, so that's x and that's y. So now our first point is going to be negative 7, 5. So negative 7, 1, 2, 3, 4, 5, 6, 7. Negative 7, 5, 1, 2, 3, 4, 5. Negative 7, 5 is going to be right about, let's just use the corner here. Right, it's not bad. It's going to be right about here. Negative 7, 5. And then we have negative 7, 8, 5, 6, 7, 8. Negative 7, 8 is going to be right there. Right? And if we drop the line that's passing through those two, what are we going to get? A vertical line. Vertical line has an undefined slope. So that's a bit of a, that one there was a bit of a trip you up sort of question, right? Because it's one of the edge cases that we wouldn't see all that often. But like I said, teachers try to pull sneaky ones on you. I got to tell you, right? So there's going to be times. There's going to be times when you have little curveball ones like that, and you got to know how to interpret your answers, right? If you were to do this and to say, no, that can't be right. It can't be 0. Maybe this is supposed to be negative 14. Maybe it's actually 3 over negative 14. No, it's not. It is actually 3 over 0. And if you draw it out, right? When in doubt, draw it out. When in doubt, draw it out. That's right. So, question 5 now, next up. To join a running club. Why would you join a running club? Can't you just go outside and run? I mean, to be fair, I do. I have a treadmill specifically, so I don't have to do that. So who am I to say that? Anyway, to join a running club, John pays a startup fee of $60 plus a monthly fee of $25. What is the equation in slope-intercept form that represents the cost in C dollars for N months of membership? Great. Okay. Perfect. So, so we know that the starting fee is equal to $60 dues, and the monthly fee is going to be $25. It's not dollary dues. I'm in Canada. You know, the antipode of St. John's, Newfoundland, the closest community to the antipode of St. John's, Newfoundland. I would ask Twitch chat to guess, but I think Twitch chat might be just me at this point. So me, are you able to guess? Why, yes, me. Yes, I am able to guess that the antipode of St. John's, Newfoundland is Perth, Australia. It's true. We're actually like a few hundred miles off the, like few hundred kilometers off the coast of Perth. But Perth is the closest city to the antipode of St. John's, Newfoundland. Right? So literally, Australia is literally halfway around the world from here. Because the antipode, it's a good teachable moment, the antipode is the place on Earth that is the furthest, exactly the furthest from another point, right? Anyway, so the starting fee is 60 bucks, the monthly fee is 25. Well, how can we figure out the equation in slope-intercept form? Well, if we were to graph this, what would the y-intercept be? Well, we know that the starting fee is going to be the y-int. And why is that? Well, because it's what we start at. Like, even if you go for 0 months, you still got to pay the starting fee of 60, right? And then it goes up by 25 every month. So we know that this is the slope because that's what it goes up by. So if we have 60 as the y-intercept, 25 as the slope, then we can go ahead, y equals 25x plus 60, or in this case we were told to use c and n, so the cost is equal to 25 times the number of months plus 60. Right? That's all you got to do for that one. Number 5 down. Next up, I was asked to do number 7. Number 7, what is the slope point form for an equation of the graphed line? Slope point form. Now, remember that slope point form has the form of y minus y1 equals m times x minus x1. Right? Where this is where x1, y1 is a point on the line. Right? So here, we can just pick any old point on that line. So let's go over. Can you see my cursor? No, you can't. Now you can see my cursor. Okay. We see here that a point on the line could be 0, -1. Actually, no, that's not quite on the line. No, well, 1, -2. So we say 1, -2 is on the line. Slope equals what? Well, let's count. Let's count from over here. Let's see, what's another point that's on the line? It looks like this one. -3, 1. So then it goes down 1, 2, 3, and to the right 1, 2, 3, 4. So that's the slope is going to be -3 over 4. Therefore, line equation is y minus, now remember we do the minus, y minus -2 is going to be here, so we can call that y plus 2, is equal to -3 over 4 outside of x minus 1. And there we go. Right? And that is the slope point form for the line in number 7. Okay, number 7 down. We need to do number 10. What is the equation in slope point form of the line that passes through those ones? So again, we've got slope point form. But this one is a little bit of a twist. Well, not a twist. It's a touch different than the last one. It's not really a twist. But we know that the line passes through -1, -6, and also through -4, 7, right? So we know that the slope, we only have to find the slope of this line, right? Because we're asked to put it into slope point form, which is still this one. This is slope point form. So the slope here, we can get it as y2 minus y1 over x2 minus x1, like that. So then that is going to be, the y2 is going to be 7, the y1 is going to be -6, right? The x2 is going to be -4, and the x1, oh, there should be a subtract here, and the x1 is going to be a -1. Right? So we have 7 minus -6 is going to be positive 13. -4 minus -1 is going to be a -3. But so we'll just call it -13 over 3. We always put the negative on top if there's one negative. It's just part of simplifying. Okay? Now we know the slope, and we know 2 points on the line, so we can pick either of these guys. Because they're both points on the line, it's going to work out to be the same thing. Right? But our slope point form, again, remember, is y minus y1 equals m x minus x1. So here, y1 is going to be a negative 6. So it'll be a y plus 6. And our m is negative 13 over 3. And this is going to be x plus 1. There we go. Or I could have y minus 7 equals negative 13 over 3 x plus 4. Because that's also a point on the line. So either one of those would work for the answer to this question, because those are the 2 points that you have been given. Okay, I was also looking to do question 12 here. Question 12, actually let me zoom this over a little bit so you can see the numbers while I'm working on them. Excuse me. So, number 12, yes. So a line has an x-intercept 18 and a y-intercept negative 8. What is the general form of the equation of this line? Now remember, general form has a 0 on one side, right? That's pretty much all you got to remember, is that a general form, that's the main thing to remember, that a general form is going to be ax plus by minus c equals 0. That's a general form. Okay, so how are we going to get it to that point? Well, we know 2 points that are on this line already, right? So we know that point, know that the x-intercept is 18, right? So if the x-intercept is 18, then we know that the point 18 comma 0 is on the line. And if the y-intercept is negative 8, we know that negative 8 comma 0 is on the line. Once we get these two guys ready, we can solve this one in a whole bunch of different ways. But I'm going to start off with y equals mx plus b because I prefer to start off this way. You can start off with a whole bunch of different ones if you want to. But the slope here, right, it's going to be negative 8. It's going to go up by 8 and to the right 18. So the rise is going to be 8 over a run of 18, right? 8 over 18, x, and then b is of course the y-intercept, which is going to be a negative 8 right there. 8 over 18 is going to be the same as 4 over 9, so y is equal to 4 over 9x minus 8. Now remember, in general form, we don't have fractions here like this, so I've got to multiply by the 9. So we'll have 9y equals 4x minus 72, or 0 equals 4x minus 9y minus 72. And then that's our answer, right? Because this is now in the general form, where a is equal to 4, b is equal to negative 9, and c, sorry, that should be a plus, c is equal to a minus 72. All right, so that's question 12. Right, Betty Ann, I know you mentioned that it would be difficult for you to see it live. If you are seeing it live, please stop me if I'm doing anything wrong or if you have any questions. So this is still Math 1101C. 1101C. And this is now let's see. This is still assignment 1. Question 13. What is the general form of the equation? Y is equal to negative 5 over 3x minus 6. Well, again, the general form, just like we got into in the last one, we're going to need to have no fractions, and we're going to need to have it to equal 0 on one side. So I'm going to multiply all these by 3. We'll have 3y equals negative 5x minus 18. And then I'm going to move this, I could just move both these guys over, so it's going to be 5x plus 3y plus 18 equals 0. And there we go. Number 13 sorted. What is the standard form of the equation this? So number 16 is the next one I'm going to do. Standard form of that equation. All right, so number 16 then is going to be 1 over 3 y minus 2 over 5x plus 2 equals 0. Right, now the standard form of the line, I always forget this one. I always forget the standard form. Yeah, standard form is just when it has the c on the other side. It's a bit of a silly one, to be honest, right? But the standard form is going to be, so we're looking to get it into ax plus by equals c. So this is the standard. So that's what we're looking to convert it into, right? So now I'm going to go ahead and I'm going to multiply both these sides by the lowest common multiple of 3 and 5, or not by the lowest common multiple, but I want to make these into sort of the same number on the bottom here so that I can get rid of them. Well, kind of what I'm doing is just trying to get rid of both of them. So yeah, I am going to multiply it by the lowest common multiple. What am I saying? So I'm going to multiply this whole side by 15. So we're going to have 15 outside of 1 over 3 y minus 2 over 5x plus 2 equals 0. So we're going to have 15 over 3, which is 5y, minus 30 over 5 is going to be 6, and it's going to be plus 30 equals 0. Then I'm going to move this to the other side and have 5y minus 6x equals negative 30. There we go. That's question 16 down. We got there. Got there, Twitch chat. We got it. We got it. So number 17 now, just the next one down, and that'll be the last one that I'm going to do on these multiple choice, or these fill-ins rather. Then I've got 2 ones to look at briefly, and we'll be done with this unit. So number 17 then, what is the equation of the line in standard form? Right, remember standard form is this guy, but with slope, so we know the slope equals negative 2 over 3, and we know the y int is equal to 4. So if we were to take it and put it into slope-intercept form of y equals mx plus b, we could just have negative 2 over 3x plus 4. Simple stuff, right? But then we want to get it into standard form. Now to get it into standard form, we need to have no fraction, and then we need to move the stuff around. So to get rid of the fraction, let's multiply both sides by 3. I'm going to call this 3y equals negative 2x plus 12. And then I'm just going to move the x's over. 3y plus 2x equals 12. There we go. That's it. So 17 down. Now I'm going to go down to number 22. Change each of the following to general form. Okay, so we're going to change these guys to general form. Now, general form is the one where there's a 0 on one side and the rest of it's all the same. So this is actually pretty similar to the one that I was just doing. So I'm going to go through these fairly quickly as well. So then 22a is going to be y equals negative, oh sorry, no negative, y equals 5 over 6 x minus 9. Multiply both sides by 6 to get rid of the fraction. 6y equals 5x minus 54. Then there has to be a 0 on one side, so I'm just going to subtract this y and move it over. 0 equals 5x minus 6y minus 54. That's it. That's all you got to do. Change the following to general form. Sorted. Next up. So then 22b is going to be y plus 8 equals negative 2 over 5 x minus 4. Right? Now the algebra stuff like this, personally, I find this to be fairly good, you know. But anyway, I'm just going to carry on. I'm going to move through this one quickly. So I'm going to multiply both sides by 5. We're going to end up with 5y plus 40 equals negative 2 outside of x minus 4. I'm going to multiply this out. Get 5y plus 40 is equal to negative 2x plus 8. Right? Now remember, all of this needs to be on the same side. So I'm going to have 2x plus 5y minus 32, sorry, plus 32 equals 0. There we go. Sorted. Look at that. Quick and easy, right? That was a long answer. You get loads of marks for knowing those ones, right? So yeah, this is great. This is good stuff. Got to be able to get those on the test, let me tell you, because that's easy marks. So graph each of the following equations on the grid provided. So, 23 I didn't need to do, actually. No, 23 I didn't need to do. 24, the slope and y-intercept of each of the following equations. Right, so it's asking us to find the slope and the y-intercept of these guys. So in order to find the slope and y-intercept, guess what I'm going to do? I'm going to put it in the slope-intercept form. Right, it just makes sense. It's right there. So this is going to be number 24, part A, right? It's going to be 2x minus 4y minus 16 equals 0. So I want to get it into slope-intercept form, right? So I want the y to be by itself on one side. Not super hard, so I'm going to move the y's over. I'm going to get 2x minus 16 equals 4y. So now, just to get in the slope-intercept form, all I got to do is get y by itself, so I'm going to divide by 4. I'm going to end up with 2 over 4x minus 16 over 4 equals y, which then, of course, becomes a half x minus 4 equals y. And there we go. Slope equals 1 over 2. Y int equals negative 4. Easy peasy. Right, and now I'm going to do, just carry on, barrel on through these guys. Let's get 24b done. Let's do it. Get it done. All right. So 5x plus 7y minus 14 equals 0. Do the same thing. Move the y's around. 5x minus 14 equals negative 7y. Negative 5 over 7x plus 2 equals y. There you go. Slope, negative 5 over 7. Y int, positive 2. Easy. Good stuff. So, Betty Ann, I hope that has answered any of the questions that you might have on that activity. So, I am getting down through these ones. Brittany, if you're still in chat, do let me know. It's really unfortunate when people come in and ask questions and they just sort of peace out. That's a little bit unfortunate. You know, I am hoping to have people interact on stream, just because I do want this to feel as much like a classroom as possible and as much like you're here talking with me live and able to interact. I feel that that's it's a really important part of the teaching experience, is to be able to ask questions in real time. Yeah, so I would encourage anyone who can to sort of stick around and to see the answers to the questions. But Brittany, since you asked a question, you sort of vanished out of the chat there. So I don't know if there's really a whole lot of point in me going over this. Right, I actually have to pop out into the next room and grab that Prism Math Purple, but I will do that page. There we go. That's nice. So, Prism Math Purple, I think it was 243, page 243. Um, I tell you what, if I show it on camera there, you're going to see all the solutions. And you did mention before that you were able to pause the video and record the solutions to the whole page. So, tell you what, Brittany, I'm going to go over page 243 in Prism Math Purple tomorrow. I'm going to prep my stuff for the stream beforehand. So what I'll do is, yeah, I'll get a picture of that page so I can put it up there in the corner so I won't have to just show the book on stream. Okay? So I am at my quitting time here. I've gone my 2 hours. Let's see, I've dropped 0.7% of my frames. Not bad. Not bad. Less than 1. Less than 1. Less than 1 frame drop, so not bad. Yeah, I don't. Let's see here. So tomorrow, like you see mentioned in my title, if anyone's still around and listening, I am going to discuss some educational games tomorrow. It's just sort of a feature that I'm going to be doing every Friday. I'm going to discuss because I'm extremely interested in game design. I have done a lot of, especially educational games. I've had some very successful projects that I've done making educational games for students. A lot of the teaching I did in the UK, some of the most successful classes I had revolved around, not really revolved around, but predominantly featured several games that I made up. There's one that's near and dear to my heart that I called Mathemagic at one point. It was made out of Magic the Gathering cards that I sort of repurposed. And then that's continued to evolve into MathWiz. Over the coming weeks, I will discuss those games as well. I'll also discuss a bit of theory and a bit of philosophy behind educational games and games and teaching. I've done quite a bit of reading on games. I've got a sort of like a well, I had a PhD application prepared, but it was a bit of a weird slant. If I ever did one, I would do it as an education project, which means I'd have to do a master's in education first, and but I do have a master's. But anyway, I was rambling about my credentials. But the point is, I am going to be talking sometimes on Fridays about stuff that I've read about games, like theory and other stuff like that. But largely, I want to talk about sort of my own approach to games. It's going to be a little bit loose and a bit off the cuff, not really like lectures or anything, just kind of like me talking about what I see as being the most important tenets of game design, especially games for learning. Because I feel that a lot of the literature that I have read on games for learning is a little bit, I mean, not to be too harsh, but a bit woefully inaccurate, woefully inadequate. Because frequently people get wrapped up in this notion of the gamification of learning, which is kind of just like turning up programs that aren't at all games with the trappings of games. And students see through that very quickly. But the core, I'm going to give you a little bit of a preview today, I guess. The core of my philosophy is that learning the game and learning the subject that you're teaching have to be one and the same. It can't be a kind of thing where the game is like, oh, look at these achievement points you get for solving these math questions. Well, guess what, genius? Every kid doing that knows that they're solving math questions. They don't, those little points that you stick on there might be appealing to the teachers who are like, wow, look at all this gamification that we have. Look how progressive we are. Look, we're using Duolingo in a language learning lesson. Look at that. We're using the Khan Academy achievement system that's built in so kids can earn points while they do their math work and watch videos. Isn't this great? Isn't this a game, kids? No, it's not. No, it's absolutely not. It's not even close to a game. Right? And kids see through that super quick. And adults would too. But for whatever reason, teachers are kind of blinded to it because we see the novelty of using technology in the classroom and using something that has the trappings of a game. It's like, ooh, look at all this. Look at how we're making learning more fun and accessible. But it's not. The truth of the matter is that a lot of video games are better at education than a lot of games that are made for education. Like you look at the way Dark Souls teaches players. Dark Souls teaches really well. Like it's the kind of game that, yeah, you got to learn. You got to learn, buddy. And let me tell you, the thing about Dark Souls is like the points that you put in. Like, look at these people beating Souls level 1 games and like Souls level 1 no hits. Like, I'm sure Hob has done that by now, hasn't he? Hasn't he done a Souls level 1 no hit? I bet he has. Um, like the man's a monster. But the point is that a game like Souls is really good because the only difference between like a god tier veteran and a complete scrub is just knowing the mechanics and knowing how to play the game. It's not like having the points invested or anything like that. It's all about learning. A game like Slay the Spire is entirely about learning. And Slay the Spire is a good example of learning math. Um, because you have to, because it's the game, because it is the game, is to learn that math. Personally, I think that a game like Slay the Spire is a little bit. The math is there. It's all there, but it's not as structured as a game would need to be if it was being used explicitly in a lesson. So the game that my sort of pet project game that I've worked a lot on is kind of like that. It's kind of like these deck building. No, it's not a deck building game. It's a pre-made deck game, but it is a card game, and it's more of a hand building game than it is a deck building game. Actually, it's very much a hand building game. Yeah, and the math that's in there is a little more explicit, but I've still tried to make it so that the math and the game mechanics are one and the same. Right? Anyway, it's a topic that I could ramble on for hours about, and I would like to ramble on for hours if y'all would want to stick around and hear it. So starting tomorrow after the stream, I'm going to try to focus my thoughts a bit instead of just blathering. But we're gonna begin a nice weekly discussion of games and learning, and I think it's something that Twitch chat will find quite interesting, right? I think it's something that people on Twitch will really enjoy. I think not that everybody's going to enjoy it, flapping around in circles here, but it's the kind of subjects that people will find interesting. I think so, and I would like to talk about it. Is basically what it is, and it's my stream, so y'all can stick around or not. Anyway, it's going to be fun. It's going to be fun. I'm going to showcase one of my simpler games that I did. It's kind of like Yahtzee meets pre-calculus. It's super simple, and it was super fun for some of my students. And then as time goes on, I'll get into more sophisticated games and to more what I see as the important theory behind it and stuff. Maybe we'll even discuss some good primary readings, like say Espinarseth and Cybertext. Fantastic book if anyone wants to get into ludology. But anyway, thanks for sticking around today. Hope the math questions helped you. I hope social distancing is finding you well. Next time I watch the health update, we will have audio the whole time instead of just for 3/4 of the time. Yeah. Thanks for being here. Stay safe out there. I'm pulling for you. We're all in this together. Keep your stick on the ice.